welcome you all in today's NPTEL online certification course on mechatronics. Today we are going to talk about data presentation systems. Okay, so there are various type of various ways in which data can be presented, and it is important in the sense that we need to know that what is happening in the system. So, it's some sort of values of the parameters or variables which is in the form of a display. Okay. Here is the essential components of mechatronic system, as I have been discussing with you, that is actuators, sensors, sensor signal being conditioned here, then sent to the digital control architecture and the output signal conditioning. Okay. And here is the graphical displays. Okay. So, I am going to talk about this today in this lecture. So, here it could be LEDs, LCDs, CRTs or any other type of display devices. Measurement system usually consists of three elements: sensors, okay, then the signal conditioners and the display, or what we call it as the data presentation elements. And these elements can be used for the presentation of data, and they can be classified basically into two types, one as the indicators and the other as the recorders. Okay. So, indicators actually gives you the instant values, instant visual indication of the sensed variable, whereas the recorder used to record the output signal over a period of time and give you a permanent record. Okay. That is there. Now, before we proceed, let us have a small discussion on the effect of measuring elements on the rest of the system, okay, and this is what we call it as the loading. So, a general point that has to be taken into account of when putting together any measurement system is the loading, okay, and it is the effect of connecting a load across the output terminal of any element of a measure system. So, this is what is going to have, that is the it is the effect basically whenever I am going to connect a measuring device into a system, it is going to affect or it is going to load the system. Okay. Means a very common example which many of you may be aware of is that of a voltmeter. Okay. When a voltmeter is connected across a resistor, then we effectively have put two resistors in parallel. Okay. So, basically if say I have a resistor and I put a voltmeter over here. Okay. So, basically this is what means that I am putting the two resistors in parallel. Okay. And if the resistance of the voltmeter is not considerably higher than that of the resistor, the current through resistor is markedly changed, and thus the voltage measurement changes. Okay. That is there. Now, let us look at this measurement system loading a little more in the detail, and loading can also occur within a measurement system, and suppose I have got a measurement system which consists of say a sensor, an amplifier and a display device. Okay. So, here if I look at this figure, so suppose I have got a voltage source and I have resistance of the sensor is there, and say this is resistance of the input here. okay, that is amplifier input is there. So, in this case we can see that it is basically this resistance acts as a voltage divider. So, the voltage across this one is going to be Vs times R in by Rs plus R in. So, this is what it is going to be there. Now, you see this voltage is getting amplified with the help of amplifier, okay, and we get this Vd. So, this amplified value is actually the G times Vn, okay, where G is the gain, and then this Rd acts as a voltage divider for that. So, this GVin, okay, is multiplied by Rd divided by R out plus Rd, okay. So, if I substitute back V in over here, okay, and simplify this, this is what we get, okay. So, we require basically R out to be very large than Rd and Rs to be very large than R in order to neglect the loading effect. Next, let us look at the data presentation elements, okay. Analog and digital meters, okay. So, the moving coil meter is an analog indicator with overall accuracy of the order of say plus minus 0.1 to plus minus 5%. The loading problem can be there because of the low resistance. The digital voltmeter gives its reading in the form of sequence of digits with accuracies as high as plus minus 0.005%, okay. And a digital voltmeter has typically a sample rate of 3 per second and an input impedance of 100 megavolt. The principle of digital voltmeter is that basically you have the analog input and there is going to be a sample and hold, and you are going to have the analog to digital converter after the sample and hold, and of course then you are going to have the counter, okay. So, that is going to be there. Next is the cathode ray oscilloscope, or what we call in short as the CRO. Okay. The cathode ray oscilloscope is a voltage measuring instrument which is capable of displaying extremely high frequency signals. Okay. A double beam oscilloscope has two separate traces to be observed simultaneously on the screen, and in storage of type of oscilloscope, that trace to remain on the screen after the input signal has ceased out, okay. And the digital storage oscilloscope digitize the input signal and store the digital signal in a memory. Then let us look at the visual display unit, or the VDU, which it is called in short. Okay. So, visual display unit is used to present the output data basically, okay. And these are two types of displays, one is the non-interlaced display and another is the interlaced display, okay. In the non-interlaced display, the image is built by varying the intensity of the spot on the screen as each line is scanned, okay. So, that is there, whereas in case of interlaced display, the two scans down the screen are used to trace a complete picture, okay. And by this the effect of flicker is considerably reduced, and on the first scan all the odd number lines are traced out, whereas in the second scan all the even lines numbers are traced out, okay. So, here this is how it is shown, the interlaced display, and this is that non-interlaced display basically. So, you have a electron beam over here, there is X flyback and there is Y flyback. The next, let us look at the build-up of characters by selective lighting. Okay, so the screen of the visual display unit is coated with large number of phosphor dots, and these dot forms the pixel. Okay, and a text character or a diagram is produced on the screen by selectively lighting these dots. Okay. So, for example, here say we have the 7 by 5 matrix of pixels. So, I have 1 to 7 rows and say 1 to 5 columns over here. So, I can get the character here as you can see that by lighting the different pixels, I can get the character say B over here. Okay. The input data to the visual display unit is usually in digital ASCII format. ASCII is short form for the American Standard Code for Information Interchange. Okay. So, for example, a 7-bit code, this is a 7-bit code, and so can be used to represent actually 2 to the power 7, that is 128 characters. Okay. And basically with the help of these 128 characters, we can write that is all the standard keyboard characters can be incorporated along with some control functions such as return. Okay. So, these things can be represented. So, this is basically as you can see how the ASCII code for the different characters basically. So, you can see the alphabets, that is A to Z, okay, and these are the ASCII code, a 7-bit ASCII code for the different alphabet character, and here are for the numbers basically. Okay. So, 0 to 9 you have the 7-bit code over here to represent it. Now, let us look at another very popular output device, that is the printers. Okay. So, there are a number of versions of printers are commercially available, and these are say a dot matrix printer or inkjet or a bubble jet printer and the laser printer. Okay. A dot matrix printer has a print head basically which consists of either 9 or 24 pins in a vertical line as shown over in this figure, and each pin is controlled by an electromagnet. Okay. So, this is how it is. So, we have the print needle over here, there is a ink ribbon, you put up paper over here, okay, there is a return spring hammer, and there is a overrun spring basically. Okay. So, this way actually when this needle impinges on this inked ribbon, you get those characters in the paper. The inkjet printer uses a conductive ink which is forced through a small nozzle to produce a jet of very small drop of ink of constant diameter at a constant frequency. Okay. And a piezoelectric crystal is used to form the drops pulse which vibrates at a frequency of around 100 kilohertz. Okay. So, you can see over here, so ink is passed from here, piezoelectric crystal is used to vibrate it, okay, and here you get the drops basically the ink drops you get it from here, and this is the principle for the inkjet printer. Then in case of bubble jet printer, actually the bubble jet printer uses a small heater as you can see over here, okay, in the print head with a vaporized ink in a capillary tube. So, producing gas bubble which push out drop of ink. Okay. So, basically here you have a heater, you have a ink, when the heater is not on, this is the case, and when the heater is on, the bubble is produced as over here, okay, and this bubble is pushed into, and the vapor bubble burst and ejects into a drop. Okay. So, the two types of ejections are there, one is the charging electrode and the other is the vertical stack of nozzles. Next, let us look at the laser printer. Okay. So, the basic elements of a laser printer is a drum, basically this one, okay, which is coated with photosensitive materials such as selenium, okay, and in the dark, actually in the dark it has high resistance and becomes charged as it passes close to the charged wire. Okay. So, this is what is there. So, as it passes near the charging wire, it becomes charged. So, what happens actually, a laser light is sent here and it goes to the rotating mirror, and it gets reflected from the rotating mirror, falls on the this cylindrical drum, and wherever the light falls, that portion of the drum actually gets discharged. Okay. So, then what happens that this drum turns basically, and there is a toner. Okay. So, this toner is conductive basically. So, the wherever it is charged actually, so that toner gets attracted over here. Okay. Then there is a corona wire basically over here, and this corona wire charges the paper actually. Okay. And when it charges the paper, then this charged paper actually gets attracted to the ink jet basically, and that ink basically gets into the paper, and then there is a fusing roller to fix the toner on the paper. Okay. So, this is how it is there. So, a light beam is used to scan, there is a 8-sided mirror, there is a toner, there is a corona wire basically which is used for charging of the paper, okay, and there is a hot fusing roller. So, currently we are able to produce 1200 dots per inch this way. Now, let us look at the magnetic recording. Okay. This is again a type of recording device, say a floppy disk and a hard disk of computer works on the concept of magnetic recording for the data storage. Okay. So, the working principle is like this. For this, a recording head which corresponds to the which responds to the input signal produces corresponding magnetic patterns on a thin layer of magnetic material, and then there is a read head basically that gives output by converting the magnetic pattern on the magnetic material to the electrical signal. Okay. The system also requires a transportation system that moves the magnetic material in a controlled way under the heads. Okay. And the basic components are thin magnetic material, recording head, read head, and the transport system. So, here is the basically working principle of the recording head which has been explained. Okay. So, when the electrical signals are fed to the coil, this one which is wound round the core, magnetic flux is produced in this core. Okay. And the proximity of the magnetic coated plastic to the non-magnetic gap means that we have a magnetic coated plastic over here and there is a non-magnetic gap, okay. And so when this is present here, basically it means that the path for the magnetic lines of flux exist through this way, and that way it magnetizes the magnetic coating which is there, okay, put in this gap, okay. So thus the part of the magnetic coating becomes permanently magnetized, and thus magnetic record is produced of the or rather due to the electrical input signal. And if we talk about the replay head, okay, or replay head, okay. So here actually the replay head uses the same mechanism basically, okay. And here what happens if we place the magnetized coating over here, that is in the air gap, okay, then the magnetic flux is induced in this core actually, okay, and this flux change in the core induces the EMF in it, okay, and that is wound in the coil, okay, and so in this coil you have the EMF produced, okay. So the output from the coil is an electrical signal which is related to the magnetic record which is there on the coating. So this way it is read, and this recording of signals in digital recording involves coded combination of bits basically, okay, and it is done with magnetism saturation in forward say represented by 0 and in reverse direction which is represented by 1. Okay. So, the bit cell on a magnetic surface might be appear as you can see over here, okay. And however, we must read each cell, and thus accurate timing point are needed in order to indicate clearly when the sampling should takes place. Okay. So, for reading of these each cell we need to have the exact timing for carrying out the sampling. Now, if we are using an external clock for this purpose, okay, then there may be a small mismatch between the timing signal and the rate at which the magnetic surface is moving under the read head. Okay, and this can miss the information, or this can result in cell being missed or even read twice. Okay. So, we need to have a certain synchronization is needed between the time it is read and the time it is clocked actually, and such synchronization is achieved by using the bit cell themselves to generate the signal for taking the samples. So, the method commonly used are, I will be discussing few of these methods, and if you want to learn more you can refer to Mechatronics by Bolton, from where you will get sufficient information. Okay. So, the next one way is the non-return to 0, or what we call it as NRZ in short, and with this system the flux is recorded on the tape such that no change in flux represents 0 and change in flux is represented by 1. However, it is not self clocking. Okay. So, you can see that here there is a flux, so it is a constant. Okay. So, and here so there is no change, so this is represented by say 0, and here there is going to be a change, so it is represented by 1. Okay. So, and this is basically magnetized and non-magnetized. Okay. This is what is represented over here. So, again this is say constant. So, again this is 1 and again this remains over here, and then there is a change over here. So, represented by 1. Okay. So, this way it can be represented. The next way is the phase encoding, okay. And in this method the cell is split into two halves basically. One half positive saturation flux and the other half is called the negative saturation flux, okay. And 0 means the first half bit is positive followed by the negative saturation flux, and 1 means the first half bit is negative followed by the positive saturation flux, okay. And the advantage for this method is that it is self locking, okay. So, here as we can see that 0 means first half bit is positive followed by the negative. So, you have the positive negative. So, this is 0, okay. And if it is negative followed by the positive, okay, that is represented by 1, okay. So, as you can see that negative followed by positive. So, that is represented by 1. So, this way this can be done. And the biggest thing is that this is self clocking. Next is the frequency modulation, okay. Self clocking and similar to the phase encoding this is, but there is always a flux direction reversal at the beginning of each cell, okay. And for 0 bit there is no additional flux reversal during the cell, and but for 1 there is an additional flux reversal during the cell. Then we let us look at the magnetic disk basically, okay. So, in magnetic disk the digital data is stored on the disk surface along concentric circle, as you can see over here. A single disk having many such tracks, okay. So, you can see that a single disk has got many such tracks, and this is divided into the sectors actually, okay. And the single read write head is used for each disk surface. Large amount of data can be stored on such assemblies of disk as 100 of gigabytes are now common. The disk is divided into sectors, and a hard disk might have about say 2000 tracks per surface and around 32 sectors, okay. So, this is how it could be. So, we have the disk read and write heads are there, okay, arm extend to move heads over the track. Then let us come on the display devices basically. So, the many display systems use light indicators to indicate on off status of or give the alphanumeric displays, okay, that is the alphabet and numbers. So, here as you can see this is the 7 segment display, okay, and there could be a 4 bit binary code input that can be used to generate input to switch on the various segment, okay, that I can explain in the next slide. And we could also have another format where we could have a 7 by 5 dot matrix, okay. So, we have 1 to 7 rows here and 1 to 5 column here, and by lighting the different elements in this one we can generate the alphanumeric characters. So, if we look at the 4 bit binary code input for that. So, suppose the binary input is 0 0 0 0, okay. So, this we could get by segment activation of, that is all the segments except the middle one, okay, that is G is 0, as we can see this is the G, okay. So, except the middle one this is there, we get a 0 number, okay. Similarly, for binary input 0 0 0 1, okay, what we get basically is 2 to the power 0, which is 1, and this 1 we can get if my B and C are lightened. Okay. So, B and C are lightened means that basically this one and this one is lightened, I can get the 1. Okay. So, like this way we can get the 7 segment display. Okay. So, for different type of binary inputs, okay, the different segments can be activated in order to get the different numbers being displayed. The light indicators for each display might be neon lamp or LEDs, that is light emitting diodes, or the liquid crystal displays, which we call it as the LCDs. Okay. Now, let us look at the light emitting diode. I have discussed this thing during my introductory classes, okay, in the first week. So, you can refer it over there also. So, these LEDs are cheap and require low voltage and low currents. Here you can see the basic form of LED, basically where reflectors are used to direct the light emitted. Okay. You can see the reflector over here, and this is the LED chip, and they reflect the light. Okay. A standard resistor of 150 ohm is used in series, and these LEDs are available as a single light display, 7 and 16 segment alphanumeric display in dot matrix format and in the bar graph form. So, here we can show the common anode connection arrangement of the 7 LEDs, as you can see over here, okay, to give 7 segments of a display of the form which I have shown previously, and inputs are elements are going active by input going low, and then we can have the other arrangement where elements are going active by input going high. Okay. So, this way. Often the output from the driver is not in the normal binary form, but in case in the BCD form, that is the binary coded decimal form. Okay. So, input to encoder. Okay. So, the driver output has then to be decoded into the required format for the display. Okay. So, the 7447 is a commonly used decoder for driving display, as you can see over here. So, you have the BCD input and you can have the 7447 the decoder to display, and this is 220 array ohm array, and then you have the display. Then dot matrix display, the basic form used for a 5 by 7 dot matrix LED display is shown over here. So, here you can see 1, 2, 3, 4, 5, there are 5 columns, and you have the 7 rows over here. Okay. And the connections are in such a way to turn a particular LED, power is applied to its column and its row is grounded. Okay. So, that is how it is done, and this display enables all the ASCII character to be produced. Then the liquid crystal displays or the LCDs, it has no light of their own, but rely on reflected light or the transmitted light. Okay. The material is compounded with long rod shaped molecules, which is sandwiched between the two sheets of polymer containing microscopic grooves. Actually, the arrangement of polymer sheets and the molecules are here, as you can see over here. Okay. So, that is there, and molecules aligns as the light transmits or not. Okay. So, that is there. Have different segment display as the LEDs, and an AC electric field of about 3 to 12 volt is used to turn on any segment. Okay. So, here as you can see that direction of polarized light and this is how the light is being direction of polarizer. So, light is getting transmitted over here. Okay. And here when the voltage is applied these molecules gets aligned basically and you do not get the light transmitted. Now, let us look at the data acquisition system. Okay. The data acquisition system is basically used these days to get the input data basically. Okay. So, this tend to be frequently used as a system as say system as analog to digital converter, processing analysis, digital to analog converter to display by the computer. Okay. So, there are computer with plug-in boards, the basic elements of the DOQ board and the DOQ system using plug-in board with a computer for the hardware is like this. You have connection to computer bus, okay, PC bus interface is there. So, you have the digital input output, analog output and analog input ports are over here. Okay. So, you have the inputs from say sensor, there is signal conditioning and then you can put it in the computer board. Data loggers are basically this is the term used in the DAQ system which allow it to work away from the computer as computer send the program will store in memory card or inserted in the logger basically. So, as you can see that you have the digital input. So, digital multiplexer is used to select the proper input. You may have the analog input also, for example say the thermocouple input. Okay. So, that is there. So, analog multiplexers are there and if you have the analog signals then amplifier has to be used and analog to digital converter has to be used. Okay. So, sample digital signal is there, your sample analog signal which has been converted into the digital signal that is there. Okay. And then you can have these things going to the microprocessor, okay, where you have the program unit and you can have a remote control of this microprocessor. Okay. And from here you can have the control signal for the multiplexer. Okay. And here from the microprocessor you could have connection for display, printer, floppy disk and the other systems. So, these are the references if you want to read further. Okay. You can refer these books specifically the Bolton Mechatronics. Thank you.